Okay, so we're going to be doing a Chemistry Unit 5 reactions review. So first up, here are some very important things that you must commit to memory. So please remember the diatomic molecules, which are Brinkelhoff. So diatomic molecules will appear in twos, right? So nitrogen, for example, will appear as N2. Oxygen will appear as O2. So when you're given an equation, always remember that Brinkelhoff, the diatomic molecules, will appear as N2, or O2, or Cl2, they'll just appear in twos. And then something else that you should remember are the polyatomic ions. So always remember the charges and the subscripts, as well as their names, because you don't want to confuse yourselves with like sulfate and sulfur, for example, because they're not the same thing. So yeah, there's nitrate, hydroxide, carbonate, sulfate, phosphate, and ammonium. Please remember these. And also remember that there's a ammonia compound. So there's the ammonia molecule and then the ammonium polyatomic ion. So if you want to write this down, ammonia is NH3 with no charge. Okay, so balancing equations. So first up, we're going to cover the law of conservation of matter. So what the law of conservation of matter states is that mass is never created nor destroyed. So therefore, in a chemical equation, everything must be balanced. So the reactant side and the product side must be balanced. What this means is that the reactants must add up to the products. So let's say we have 5 oxygen in the reactant side. To balance the equation, there must be 5 oxygen in the product side. So if an equation had like 2 hydrogen in the product side, but it had 5 hydrogen in the reactant side, we must balance this and manipulate the variables so that it conforms to the law of conservation of matter. All right, so let's look at this diagram. So the coefficients are the numbers that go in front of the whole molecule. So the coefficient will tell you how many of each molecule there are. Okay, and then this small number here is the subscript. The subscript will tell you how many of that each element there is. So this tells you that there's 2 hydrogens. This tells you that there's 2 oxygens. Okay, and then over here you can see that there's a coefficient on the whole molecule. So this 2 applies to the hydrogen as well as the oxygen. So when you do it's called atom inventory, there would be 4 hydrogen and 2 oxygen. Okay, so let's look at this. This is a balanced equation, and it's balanced because the charges add up to 0 and the products and the reactants are equal. So there's 4 hydrogen in the reactant side and there's 4 hydrogen in the product side. There's 2 oxygen in the reactant side and there's 2 oxygen in the product side. Alright, so yeah, charges must always equal 0 and there must always be an equal amount of each element on the reactant and product side of the equation. So let's look at this problem. So on the reactant side, we're given nitrogen. So that's just going to be N2 because nitrogen is a diatomic molecule, right? So yeah, nitrogen is diatomic, so it appears as N2. And also remember that nitrogen has a charge of -3. Okay, so we're told that nitrogen reacts with hydrogen to form ammonia. Remember, this is ammonia. So nitrogen is also a diatomic molecule, so it's going to appear as H2. Okay, so when we're balancing the equation, we need to look at charges, right? Okay, So the reason why we're given NH3 instead of like NH is because hydrogen has a +1 charge, whereas nitrogen has a -3 charge. So to balance this molecule, we must have 3 hydrogen, so that the charges are -3 + 3, which equals 0. Okay, and we are going to put a 2 coefficient in front of the products because we're given 2 nitrogen in the beginning, which means to balance this, we must have 2 nitrogen in the product side. Okay, so now that we know that there's 2 nitrogen on the reactant side and 2 nitrogen on the product side, we should look at the hydrogens. So 3 times 2 is 6. So that means there's 6 hydrogen on the product side, so we must balance the reactant side to have 6 hydrogen. So to do that, we're going to do 6 divided by 2, and we're going to get 3. So there's going to be a coefficient of 3 on the hydrogen. All right, so let's look at this. So yeah, since hydrogen has a charge of +1, we need 3 hydrogen to balance N, which is nitrogen. Okay, so let's do this practice. Okay, so first up we have 3 carbon on the reactant side. So the first thing I'm going to do is I'm going to put a coefficient of 3 in front of the carbon dioxide, because that's going to balance out the individual carbon. Okay, so now we have 3 carbon on the reactant side and 3 carbon on the product side. The next thing I'm going to do is I'm going to go on to the next element, which is hydrogen. So there's 8 hydrogen on the reactant side, and over here there's 2. So I'm going to do 8 divided by 2, which is 4. So I'm going to put a coefficient of 4 here. That way there's 8 hydrogen on the reactant side and 8 hydrogen on the product side. So now to balance this, I'm going to look at the oxygen. So on the product side, there's 6 oxygen, because remember this 3 also transfers over and distributes the oxygen. So this is 6 plus 4. So that's 10. So 10 divided by 2 is going to give you 5. So that means we need to put a coefficient of 5 on the reactant side. So let's add this up. 3 carbon, 3 carbon. 8 hydrogen, 8 hydrogen. 10 oxygen, 6 plus 4 oxygen, which is 10. So this is balanced. So that's our final equation. Okay, so try doing this one on your own. You can pause the video. Okay, so I'm going to look at iron. So there's 1 iron on the reactant side and 3 iron on the product side. So I'm going to put a coefficient of 3 here. Okay, and then there's 4 oxygen on the product side, and there's only 1 on the reactant side. So I'm going to put a coefficient of 4 in front of the H2O. But now that we've done that, if you look at this, there's going to be 8 hydrogen. But on the product side, there's only 2. So we're going to put a coefficient of 4 on the hydrogen in the product side so that this is balanced. Okay, so 3, 3, 8, 8, 4, and 4. So this is our final equation. Okay, so now we're going to be going over types of reactions. So our first reaction is the synthesis reaction, which is where 2 or more substances combine to form a single product. So you can tell something is a synthesis reaction if you start off with 2 or more substances and it forms only one product. So here's like the model equation. So it's A plus B equals AP. So notice how there's 2 elements and it forms one product. So let's look at an example. Okay, so you're given 2 elements And since we know it forms a single product, we can just put these together. So it's going to form carbon dioxide. Okay? And then there's 1 carbon on each side and 2 oxygen on each side, so that's good. Okay, another example. Okay, over here, this one's more complicated. So we're given 2 molecules, and it's going to form a single product, right? So when we put this together, we're going to know that, like, this is calcium, right? So calcium has a +2 charge. So this oxygen here can actually be like rewritten as hydroxide when you're adding these together, right? So hydroxide is a polyatomic ion. Hydroxide has a -1 charge. And since calcium has a +2 charge, we need to put a subscript of 2 here. But the reason why we're not putting OH2 with no parentheses is because that would mean the 2 does not distribute to the oxygen. We need to put brackets, parentheses, to show that this is hydroxide, and the 2 would distribute to the oxygen and the hydrogen. Okay, so here are some common mistakes. So never forget nomenclature. So what this means is that the metal must go before the non-metal when writing an ionic equation. So remember that transition metals have varying charges, so you must look at the context of the problem. So for example, if we're given copper 2, then the charge of copper is 2. The next type of reaction is the decomposition reaction. So this is when a compound will separate into 2 or more simpler substances. So here's the general equation. AB will turn into A plus B. So you're given a compound and it turns into 2 simpler compounds or elements. So here is a example. So here we're given water. And since this is going to turn into 2 simpler substances, let's just assume that it's going to break down into hydrogen and oxygen. So yeah. So notice that this is balanced, right? So O2 has to appear as O2. Oxygen has to appear as O2. So that's why we have a subscript 2 here, so that everything can distribute and there's equal charges. So let's count. 4 hydrogen, 2 oxygen. 4 hydrogen, 2 oxygen. That's balanced. Let's look at another example. So try this one for your own and pause the video. Okay. So this is going to break apart into carbon dioxide and sodium oxide. Okay, the next type of reaction is the combustion reaction. So pay attention to this. A combustion reaction is an exothermic reaction, which means it releases heat. And what happens is oxygen is combined with a hydrocarbon, which is an alkane. Remember, methane, ethane, butane, just remember your alkanes, right? And what happens is it forms heat as well as water and carbon dioxide. So you're basically given the whole equation. So on your test, you're probably going to see like a combustion reaction of butane forms blah, blah, blah. So that's all you're going to be given. But you can figure it out because you know it's combustion, which means you know it reacts with oxygen to form water and carbon dioxide. So here's the general equation. So this represents a hydrocarbon, and it reacts with water to form carbon dioxide. Oh, sorry. Should be a 2. Carbon dioxide and water. Okay, so here's an example. So the reaction between methane and oxygen. typically it would say like a combustion reaction forms with methane. Okay, so we know methane is CH4. This you should just commit to memory, and I'm pretty sure you learned these in other units, so you should be fine. Okay, so oxygen, so O2, because remember, diatomic. Okay, so a combustion reaction will form water and carbon dioxide, right? So generally, we're just going to put H2O and CO2. Now, let's say you're given octane. You would need to do a lot of balancing to balance out this hydrogen with this hydrogen, right? Okay, so let's look at this. The reactant side has the reactant side has 1 carbon, product side has 1 carbon. Reactant side has 4 hydrogen, product side has 2 hydrogen. So let's balance this. To balance this, we're going to put a 2 coefficient in front of the water. The reason why we're putting a coefficient of 2 is because we cannot mess with the subscripts. Because messing with the subscripts would mess with the charges, right? So you need to put a coefficient. Yep, coefficient of 2. So let's count this. 4 hydrogen, 4 hydrogen. But then, putting this coefficient here messes with this oxygen. So on the reactant side, we have 2 oxygen. On the product side, we have 2 plus 2, which is 4. So we need to put a coefficient of 2 in front of the oxygen in the reactant side so that that can balance out to 4 oxygen to 4 oxygen. We cannot mess with the subscripts because you should not mess with the subscripts. Okay. So yeah, that's our final equation. Okay, so our next type of reaction is a single replacement reaction. You could also call this a single displacement reaction. So an element and a compound will react to form a different element and a compound. So yeah, A plus BC will form B plus AC. Notice that because we're forming AC and A is first, according to nomenclature, A must be a metal, which means B is a metal, which means C is a nonmetal. So remember, the metal, okay, so let's say A is metal. A metal has to displace another metal. The metal cannot displace a nonmetal, meaning A plus BC cannot form AB plus C, because both A and B are nonmetals. So yeah, a nonmetal can replace a nonmetal, or a metal can replace a metal. You must be aware of the fact that in a single replacement reaction, you can have a nonmetal replacing a nonmetal, but you cannot have a nonmetal replacing a metal. So please pay attention to that. Okay, so in our first example, we're going to be looking at a metal replacing a metal. So let's identify the metal. Zinc is the metal. In the compound, the metal is always going to be the first element, because according to nomenclature, the metal goes first, right? So this is copper. So let's predict the products. Since zinc is going to be displacing copper, we're going to form zinc chloride. Okay, so ignore this for now. Okay, so here's another example with a nonmetal replacing a nonmetal. So we're going to have sodium iodide plus chlorine. So chlorine is a gas, it's a nonmetal, which suggests that this iodine is going to get displaced. So we're going to predict that we're going to form NaCl, which is salt and then iodine alone. Yeah. So NaCl is formed because an ionic bond is stronger than a covalent bond. So we're not going to form like iodine and chlorine, because chlorine is going to displace the iodine. Okay, so let's go over the double displacement reaction. So a double displacement reaction is quite similar to a single displacement reaction. The difference is that there are two ionic compounds in the reactant side, which forms two ionic compounds in the product side. So essentially what happens is AB plus CD will equal AD plus CD, CB. So A and C are the metals, and B and D are the nonmetals. So what happens is the metal will displace the other metal, so that you're given a new metal and metal, non-metal and metal bond. So A will displace C, so that it becomes AD. C will displace A, so that you're given AB. Remember this. You will never get a metal and a metal bonded together, or a non-metal and a non-metal bonded together. This is because you need ionic equations, right? So you'll never have AC or BD together. And always be aware of this. So let's look at an example. So this is a metal replacing a metal, and which will always be your case. Okay, so the metal here is sodium, and the metal over here is silver. So what will happen is sodium will replace silver. So now what you're going to have is NaNO3. In other words, it's going to be sodium nitrate. Sodium has a +1 charge, and nitrate has a -1 charge. So that's going to cancel out to be 0. Silver has a +1 charge, and chlorine has a -1 charge, so that's also going to be 0. So yeah, notice how this sodium is taking this nonmetal. This silver is taking this nonmetal. They're just switching. Okay? So yeah, remember the metal will always go first. And this is due to our rules in nomenclature where the metal will always go first. So something that I noticed is that a lot of people are going to be writing nitrate sodium, but that's not right because nitrate is a nonmetal. And also something else to notice is that a precipitate is formed. So we're going to be going over what a precipitate is and how to figure out what it is. So precipitates are the insoluble substance that does not dissolve in an aqueous solution. So the precipitate is formed as a product of a aqueous double displacement reaction, and it's always going to be like your solid. A net ionic equation is basically just your ionic equation that shows what the precipitate is. So it's just going to take the molecules that form the precipitate. Your spectator ions are the ions that do not cause a precipitate to form. Okay, so let's take a look at our example. So notice this is our precipitate, and then if you look at the net ionic equation, it's basically just going to be whatever creates the precipitate. So it's just going to be like silver plus chlorine. And we're going to be going over how to write this. So in order to determine what the precipitate is, you're going to look at your solubility rules. So NAG-SAG is a mnemonic that I like to use to determine what the soluble substance is. So NAG-SAG refers to nitrates, acetates, group 1 metals, sulfates, ammonium, and group 17 gases. Exceptions would be if any of these things are bonded to lead, mercury, silver, calcium, strontium, and barium. So if you look at this example, silver is bonded to chlorine. So although chlorine is a group 17 gas, it would typically be soluble, but since it's bonded to silver, it's going to be insoluble. So yeah, just commit this chart to memory. So let's look at this example. So try to do this on your own. Try to predict the equations and let me know how you do. Okay, so sodium is one of your metals and barium is one of your metals. So sodium is going to displace barium, so you're going to be left with NaCl because they switched. So let's remember charges. Na has a +1 charge. Cl has a -1 charge. They're going to cancel out to be 0. So you do not need to put any subscripts. If you put subscript like Na subscript 2, Cl subscript 2, just cancel that out. And then let's predict your next one. It's going to be barium sulfate because barium displaces sodium, so you're going to be left with BaSO4. Look at the charges. Ba has a charge of +2, sulfate has a charge of -2, so that balances out. And now remember to balance out your equation. So there's 2 sodium on this side, 2 sodium on the product side. That's balanced. Looking at your solubility rules, let's determine what the soluble substance is and your insoluble substance is. So for NaCl, first of all, we know that NaCl is salt, and we know that salt dissolves in water, so we can already predict that this is going to be insoluble or soluble. But let's look at the chart. So it's a group 1 and a group 17, so that's soluble. As for BaSO4, barium is one of your exceptions. So although sulfate is soluble, since it's bonded with barium, it's going to be insoluble. So yeah, this is what you're going to be left with. Your precipitate is barium sulfate. Okay, so now we're going to learn how to write a ionic equation and a net ionic equation, as well as predicting the spectator ions. A net ionic equation is basically where you take the full balanced equation and you just break it down into ions. So you look at the charges. So sodium has a +1 charge, so you're just going to turn this into sodium +1. Since there's a subscript 2, all subscripts will turn into coefficients. So yeah, 2 Na +1, notice the 2 is from the subscript. Sulfate, which is a -2. The reason why the 4 is not turned into a coefficient is because it's a polyatomic. So remember, polyatomics, remember that. Barium and chlorine, remember, there's a 2 here. And also remember that your insoluble substance will always be written as a solid. It's not going to be broken apart, so it's always going to be insoluble. So let's look at the spectator ions. Spectator ions are the ions that do not play a role in creating the precipitate. So if you look at this, spectator ions are going to be the same on both sides. So you notice you have an Na here, you have an Na here. So this is one of your spectator ions. You can cross that out. Okay, and now let's see. Chlorine here, that's one of your spectators. Cross that out. Now let's look at your net ionic equation. Your net ionic equation is going to be whatever substances create your aqueous or insoluble precipitate. So that's going to be your sulfate and your barium, which will create BaSO4, barium sulfate. So that's your net ionic equation. Remember, always put the charges and always put the state of matter. So AQ, solid, always remember those. Okay, so try doing this on your own. So this is a word problem. Aqueous sodium hydroxide reacts with copper 2 nitrate to form an aqueous solution and a precipitate at the bottom. This 2 here indicates it's a transition metal, which means it has a charge of 2. So sodium hydroxide, look at the charges. Sodium has a +1 charge, hydroxide has a -1 charge. That's going to be NaOH. And then copper 2 and nitrate is NaNO3, and it has a -1 charge. So the reason why we put a subscript 2 outside of the parentheses is because your polyatomic ions always need to have parentheses around them when you're doing charges. You cannot put the 2 in front of like the 3 because that's saying there's 6 oxygen and it's not distributing the 2 to the nitrogen. The reason why there's a 2 here is because copper has a +2 charge, whereas nitrate has a -1 charge. To balance out the charges, you're going to multiply -1 times 2 so that you have +2 minus 2, which equals 0. So your charges always have to equal 0, remember that. Let's predict the products using double displacement. Na will displace copper, so you're going to be left with NaNO3. Copper will displace sodium, so you're going to be left with CuOH. Now let's balance. Look at the charges. Over here, on the reactant side, you're given 2 nitrates. But on the product side, you only have 1. That's why we have a coefficient of 2 to balance this out. But then, since we have a coefficient of 2, we have 2 sodium, so we have to move a coefficient of 2 over here to balance that out. Now if you look at copper hydroxide, copper has a +2 charge, whereas nitrate has a -1 charge. Adding those up, you're going to be left with a charge of 1. Remember, your charge has to equal 0. So we're going to multiply -1 times 2 to equal -2, so you're left with 2 minus 2, which equals 0. And this is your solid because solubility rules. Your full net ionic equation will be turning these into ions. Remember that your insoluble substance will always be written as the solid. Spectator ions will be whatever occurs on both sides, so sodium, nitrate, nitrate. Your net ionic equation will be whatever creates your precipitate. So it's going to be hydroxide and copper. Okay, let's go over the last few equations. So a neutralization reaction is where you have an acid and a base, and it forms water and a salt. So your acid is always going to be containing a hydrogen, whereas your base will always contain a hydroxide. So let's look at this. This is your general equation. So your H, this is your acid. Your OH is your base, it's your salt and your water. Let's look at our example. Okay, so let's identify the acid. The acid is going to be containing your hydrogen, so it's your HCl. Your base is going to contain your hydroxide, so it's NaOH. And it's going to produce your salt and your water. So you can use the same method as a double displacement where Na will displace hydrogen, so you're left with NaCl. Hydrogen will displace your sodium, so you're left with water. Remember to balance the charges. So yeah, this is your acid, your base, your salt, and your water. And remember, water is going to be liquid, and this is useful because when you're given a net ionic equation, it's going to be finding the net ionic equation for water. So yeah, you can try doing this on your own, but this is just gonna like show you how to do that. So yeah, this is your net ionic equation. Now let's go for your last type of equation, which is a polymerization reaction. This is the process where you create polymers. So you're given monomers and you create a polymer. And that's all. Thanks for watching, and I hope you learned something and you're ready for your test.